Ewald's formula integral of 0 to pi by 2 sin power mx cos power nx dx. ఈ ఫార్ములాని సింపుల్గా గుర్తుపెట్టుకోవాలంటే ఫస్ట్ బిగిన్ విత్ m minus 1 and go on writing the terms reducing to each term. m minus 1 reducing to m minus 3, m minus 5 and so on 2 or 1 into, and next begin with n minus 1 and reducing to every term n minus 3, n minus 5 and so on 2 or 1 into whole divided by begin with m plus n first term and reducing to each term m plus n minus 2, next m plus n minus 4 and so on 2 or 1 into 1 or pi by 2 into pi by 2 ఎప్పుడు యూస్ చేస్తామంటే both m and n are even, both m, n even. ఈ 1 ఎప్పుడు యూస్ చేస్తామంటే అదర్వైజ్ కేసులో, అదర్వైజ్ సింపుల్గా గుర్తుపెట్టుకోవాలంటే ఫస్ట్ బిగిన్ విత్ m minus 1 and reducing to each term and so on 2 or 1. Next starting with begin with n minus 1 and reducing to and so on 2 or 1 by denominator begin with m plus n and reducing to each term and so on in 2 or 1 into 1 or pi by 2. This term into pi by 2 when both m and n are even into 1 otherwise case. One problem based on this Ewald's formula, integral of minus pi by 2 to pi by 2 sin power 4x into cos power 6x dx is equals to first option 3 pi by 128, second option 3 pi by 256, third option 5 pi by 128 and fourth option 7 pi by 128. Solution: integral of minus pi by 2 to pi by 2 sin power 4x cos power 6x dx. అయితే మనకి Ewald's ఫార్ములా ఓన్లీ 0 to pi by 2 లిమిట్సే, 0 to pi by 2 లిమిట్స్. So that this can be written as 2 into integral 0 to pi by 2 sin power 4x cos power 6x dx. Since integral of minus a to a f of x dx is equals to 2 into integral 0 to a f of x dx, if f of minus x is equals to plus f of x and is equal to 0, f of minus x is equal to minus f of x. So this is the condition, minus a to a f of x dx is equal to 2 into integral 0 to a f of x dx if f of minus x is equal plus f of x. So function there is no change, sin power even numbers ఉన్నాయి కాబట్టి that is equal. Now applying Ewald's formula 0 to pi by 2 sin power mx cos power nx, m n రెండు కూడా ఈవెన్ నంబర్సే. సో 2 into first we begin with m minus 1, ఫార్ములాలో m minus 1 4 minus 1 3, next reducing 2 terms each term, so m minus 1 3, m minus 3, m minus 3 4 minus 3 1, and next there is no possibility in this term. Next begin with n minus 1 6 minus 1 5, next n minus 3 6 minus 3 3 into next n minus 5 1 by denominator begin with m plus n 4 plus 6 m plus n into m plus n reduced with 2 terms m plus n minus 2 8 next 8 minus 2 6 minus 2 4 minus 2 2 into pi by 2. Because of multiplying with pi by 2 m1 and n are even, so simplifying that is equal to 2 will go, 3 2s are 6, numerator 5 into 3 divided by 6 plus 4 10 into 8 into 2 into 4 into pi by 2. 5 goes 2 times, that is equal to 3 pi by 8 2s are 16, 16 into 4, 64, 64 into 4, 64 4s are 256. So 3 pi by 256 is the solution. 3 pi by 256 is the solution. Areas based on the completely solve the given problems, it is very easy to first draw the figures, right? First one, let f of x be a function, be a continuous function on closed interval a comma b. The area of the region bounded by the curve y is equal to f of x, y is equal to f of x with x-axis, and the lines x is equal to a, x is equal to b is area A is equal to integral of a to b f of x dx. F of x is greater than or equal to 0 above the x-axis. This is a figure, a general figure, x-axis, y-axis, the lines x is equals to a, x is equals to b, which is parallel to y-axis, and it is the given curve y is equals to f of x, y is equal to f of x. This is the required area we have to find. This is above x-axis. To find the area of this region, this region within the limits x-axis, x is equal to a, x is equals to b, and the given curve y is equal to f of x with x-axis. And the area, next one, the area bounded by the curve, the area of the region bounded by the curve y is equals to f of x with the x-axis, and the lines x is equal to a, x is equal to b is area A is equal to integral of a to b minus f of x into dx if f of x is less than or equal to 0. So this is x-axis, this is y-axis, x is equal to a, x is equal to b lines, and it is the given curve y equal to f of x, y is equal to f of x. Below the x-axis, it is the required region. We have to write integral a to b minus f of x dx from these two conditions, and that is, this can be written as area never be negative. Therefore, a is equal to modulus of integral of a to b f of x into dx, f of x into dx. సో జనరల్గా మనం ఏరియాస్ని ట్రయాంగిల్ ఏరియా అయితే చెప్పొచ్చు, సర్కిల్ ఏరియా, రెక్టాంగిల్, స్క్వేర్స్, ఇవి డెఫినెట్ షేప్స్లో ఉంటాయండి. డెఫినెట్ షేప్లో ఉంటాయి. ఇండెఫినెట్ షేప్స్లో ఉన్నటువంటి ఏరియాస్ని ఫైండ్ అవుట్ చేయడానికి మనం ఇంటిగ్రేషన్, డెఫినెట్ ఇంటిగ్రల్స్ యూజ్ చేసుకొని మనం ది గివెన్ కర్వ్ బౌండెడ్ విత్ x-axis and the lines x is equal to a, x is equal to b. Above x-axis ఉంటేనేమో a is equal to area, capital A means required area. A is equal to integral a to b f of x dx. F of x should be greater than or equal to 0. and in case below x-axis ganaka unte given curve with coordinates with x-axis and x is equal to x is equal to b, these are called ordinates also. Lines are ordinates, x is equal to x is equal to b. Therefore a is equal to integral of a to b minus f of x dx, f of x less than or equal to 0. That is area manaki eppudu negative lo undadu kabatti you can applying mod function, area a is equal to modulus of integral a to b f of x dx. F of x be a continuous function on closed interval ab, is a continuous on closed interval ab such that a is f of x is greater than or equal to 0, f of x is greater than or equal to 0 for all x belongs to closed interval a to c, and f of x is less than or equal to 0 for all x belongs to closed interval c to b, for all x belongs to closed interval c to b. Now the area of the region bounded by the curve y is equal to f of x, the x-axis and the lines x is equal to a, x is equal to b is given by a is equal to integral of a to c f of x dx plus integral of c to b minus f of x dx. That is a is equal to, a means required area, integral of a to c f of x dx plus modulus of integral c to b f of x dx. So for this diagram, x-axis, y-axis, and it is the origin, x is equals to a, and this is x is equals to b, and there exists a c belongs to closed interval ab. So from this integral a to c f of x is greater than or equal to 0. So above x-axis, above f of x greater than or equal to 0 for all x belongs to closed interval a to c, and f of x is this, for this curve it is less than or equal to 0 below x-axis. So it is closed interval c to b. So that's why integral a to c f of x dx, it is because of f of x is greater than or equal to 0 above x-axis, and c to b minus f of x dx below x-axis, that's why negative. So but area never be negative, that's why you can use mod function for this second term. Therefore that is a equal to integral a to c f of x dx is equal to modulus plus c to b modulus of c to b integral of modulus of integral c to b f of x dx. F of x and g of x are two functions. F of x and g of x are two functions defined. F of x and g of x are two functions defined on closed interval a comma b. F of x is less than or equal to g of x for all x belongs to closed interval a comma b. F of x is less than or equal to g of x for all x belongs to closed interval a comma b, then the area bounded by the curve y is equal to f of x, y is equal to g of x and the lines x is equal to a, x is equal to b is integral of a is equal to integral of a to b. See this figure. This is x is equal to a and this is x is equal to b. This is the curve y is equal to f of x, y is equal to g of x, and this is the curve y is equal to f of x. F of x is less than or equal to g of x means g of x is the upper curve, f of x is the lower curve. So its area is integral of a to b g of x dx, upper curve, area of the upper curve g of x dx minus integral of a to b f of x dx minus integral of a to b f of x dx. In case g of x is less than or equal to f of x, g of x is less than or equal to f of x for all x belongs to closed interval a comma b. Therefore, area A is equal to integral of a to b f of x dx minus integral of a to b g of x dx. Therefore, area A is equal to integral of a to b f of x dx minus integral of a to b g of x dx. F of x and g of x are two functions defined on closed interval a comma b. F of x less than or equal to g of x means g of x is the upper curve, f of x is the lower curve. For all x belongs to closed interval a b, then area bounded by these curves y equal to f of x, y equal to g of x, and the lines x is equal to a, x is equal to b with x-axis. With x-axis is a is equal to area of the upper curve minus area of the lower curve. ఇదే కేసు కాకుండా ఎఫ్ ఆఫ్ ఎక్స్ అప్పర్ కర్వ్ ఉండొచ్చు, జీ ఆఫ్ ఎక్స్ లోయర్ కర్వ్ ఉండొచ్చు. ఆ కేసులో ఇంటిగ్రల్ ఏ టు బి ఎఫ్ ఆఫ్ ఎక్స్ డిఎక్స్ మైనస్ ఇంటిగ్రల్ ఏ టు బి జీ ఆఫ్ ఎక్స్ డిఎక్స్. సో ఎనీవే ఏదైనా సరే ఏరియా అనేది నెగిటివ్ ఉండదు. దట్స్ వై ఇంటిగ్రల్ ఏరియా ఏ ఈజ్ ఈక్వల్ టు మాడ్యులస్ ఆఫ్ ఇంటిగ్రల్ ఏ టు బి ఎఫ్ ఆఫ్ ఎక్స్ డిఎక్స్ మైనస్ ఇంటిగ్రల్ ఏ టు బి జీ ఆఫ్ ఎక్స్ డిఎక్స్. ఎఫ్ ఆఫ్ ఎక్స్ అండ్ జీ ఆఫ్ ఎక్స్ are continuous functions on closed interval a comma b, and c belongs to open interval a comma b such that f of x is less than g of x for all x belongs to open interval a to c, closed interval a to open interval c, and g of x is less than f of x for all x belongs to open interval c to closed interval b, with then area of the region bounded by the curves y is equal to f of x, y is equal to g of x, and the lines x is equal to a, x is equal to b is given by area A is equal to integral of a to c, see x-axis, y-axis, this is x is equal to a and x is equals to b, and here C belongs to open interval AB. Now integral, that is the first curve, g of x, f of x is less than g of x, means this is g of x, y is equal to g of x. From closed interval a to c, f of x is less than, so this is the curve y is equal to f of x. Closed interval a to c, closed interval a to c, f of x is less than g of x. G of x is upper curve, f of x is lower curve. Shaded this area, and open interval C to closed interval B. Closed interval B, here this is the upper curve, and g of x is a lower curve. G of x is a lower curve. Therefore, area is equal to A to C, g of x minus f of x dx. First part, A to C. A to C, upper curve minus lower curve into dx plus integral of C to B. Next upper curve is f of x minus lower curve is g of x. F of x minus g of x into dx. Therefore, that is equals to integral of A to C modulus of f of x minus g of x dx plus integral of C to B f of x minus g of x dx. Two curves are intersecting at a point C, where C belongs to closed interval a comma b, C belongs to open interval, closed interval a comma b. Therefore, in this region, g of x is upper curve from x is equal to a to x is equal to c. That's why this is upper curve, and y is equal to f of x is lower curve. And from c to b, f of x is goes to upper curve and g of x go down, this is lower curve. So this area plus this area, that is equal to total area of the given two functions formed by the lines x is equal to a, x is equal to b. In some regions, to find the area, of the given curve with y-axis. ఇప్పటి వరకు మనం with x-axis తో and the lines x is equal to a, x is equal to c తో చేసాము. That is, ఇప్పుడు some regions, to find the area of the region bounded by the curve with y-axis, and the lines, this is y is equal to c and this is y is equals to d, are the two lines parallel to y is equal to c, parallel to x-axis, right? Y is equal to d, and this is the curve, x is equal to g of y. Previously, y is equal to f of x is a curve. Y is a function in the variable x. Here x is a function in the variable y. To find the limits of this function, we can applying area ni manam with x-axis tone find out cheyalani rule em ledandi, with y-axis and the lines y is equal to c, y is equal to d, bounded by the curve x is equal to g of y, right? It is the required area of the given curve x is equal to g of y and the lines y is equal to c, y is equal to d. This can be written as area A is equal to integral of c to d x into dy, where x is a function in the variable y, that is equal to integral of c to d x is g of y into dy, Next, if you two curves are intersecting with bounded with x-axis, with y-axis, this is y is equal to c and this is y is equal to d, and this curve is x is equal to f of y, and this curve is x is equal to g of y. ఈ టైప్లో ఉన్నప్పుడు రైట్ మోస్ట్ కర్వ్ మైనస్ లెఫ్ట్ మోస్ట్ కర్వ్. హియర్ రైట్ మోస్ట్ కర్వ్ ఈజ్ x is equal to g(f)(y), left most curve x is equal to g(y). Therefore, area A is equal to integral of C2D f(y) minus g(y) into dy. f(y) minus g(y) into dy. That is area A is equal to integral of C2D, where x is equal to f(y). Function is in the variable y. So x rightmost curve RC minus given function leftmost curve into dy. The area question, the area bounded by y is equal to x square plus 2 x-axis, x is equal to 1 and x is equals to 2 is first option 16/3, 17/3, 13/3, 20/3. The area bounded by the curve y is equal to x square plus 2. మనకి y is equal to x square అనేది ఒక parabola. y is equal to x square. It is a right open upward parabola. Sorry, not right open. It is a upward parabola. x square equal to 4ay form లో ఉంది కాబట్టి y is equal to x square plus 2 is there. Total curve is y is equal to x square plus 2. Actually, first draw the figure. X-axis and y-axis 0. It is 2 units above x-axis. Y is equal to x square. It is a standard form of the parabola x square equal to 4ay, whose vertex is 0, 0. But given curve is y is equal to x square plus 2. That's why to move 2 units above x-axis, రెండు యూనిట్స్ మనకు పైకి జరిగితే ఈ కర్వ్ ఇలా ఉంటుందండి. ఇది y is equal to x square plus 2 కర్వ్. నెక్స్ట్ లిమిట్స్ x is equal to a, x is equal to b. By the definition of find the area of the given function f of x with x-axis and the lines x is equal to a, x is equal to b is integral a to b. See, x is equal to 1, x is equal to 1, this is x is equal to 1, x is equal to 2, x is equal to 2. To find this area in between x is equal to 1, x is equal to 2, therefore required area solution, required area A is equal to integral of 1 to 2 y dx, that is equal to integral of what is y, given function f of x, 1 to 2 x square plus 2 into dx. Now find its integration. X square integration x cube by 3 plus 2 integration 2 constant x limits 1 to 2, that is equals to upper limit, substitute upper limit 8/3 plus 4 minus lower limit 1/3 plus 2, that is equals to 8/3, 8 plus 12/3. Next minus 1 plus 6/3, that is equal to 20/3 minus 7/3, 13/3 square units. 13/3 square units, which is the required solution of the given problem. Next problem, the area in square units the area in square units of the region bounded by the curve x square equal to 4ay, x square equal to 4y, the line x is equal to 2 and the x-axis is first option 1, second option 2/3, third option 4/3, fourth option 8/3. So manam diagram draw cheddamandi. First x-axis, y-axis, x square equal to 4ay, x square equal to 4y curve is which is in the form of x square equal to 4ay, x square is equal to 4y. The area of the region bounded by this curve x square equal to 4y, the line x is equal to 2, x is equal to 2 which is parallel to y-axis, this is x is equal to 2. Area formed with y-axis, the x-axis and the line, this is the required area. 0 whose vertex is 0, 0, 2 and x is equal to 2 is given clearly. So with x-axis annadu and the x-axis annadu, x-axis to curve chese area ekkadi nunchi andi 0 nundi x is equal to 2 varaku annadu. So this is the required area. So limits x is equal to a, x is equal to b. Here x is equal to a means y-axis x is equal to 0. Now solution, required area a is equal to integral of 0 to 2 y dx, that is equal integral of 0 to 2 y is equals to x square by 4, manam y dx x square by 4, దీని నుంచి y వాల్యూని x square by 4 into dx, 1/4 కాన్స్టెంట్ అవుట్ సైడ్ రాస్తాము, ఇంటిగ్రల్ 0 to 2 x square dx, that is equal 1/4 into x square integration x cube by 3 limits 0 to 2, that is equal 1/4 into 2 cube 8/3 minus lower limit 0, that is equals 1/4 into 8/3, 2 times cancel, that is equal to 2/3, which is the solution of the given integral, given area. Next problem, the area in square units, of the region bounded by x square is equal to 8y, x is equal to 4 and x-axis is options, first option 2/3, second option 4/3, third option 8/3, fourth option 10/3. Solution, first draw the graph of the given problem, a rough diagram, x-axis, y-axis, x square is equal to 8y, which is the standard form of the parabola, upward parabola, x square equal to 8y. మీకు తెలుసు parabola x even power of x which is symmetrical about y-axis, even powers of y which is symmetrical about x-axis, and x is equal to 4 is given, x is equal to 4, x is equal to 4, and its required area is integral of 0 to 4, required area A is equal to integral of 0 to 4 y dx, that is equal integral of 0 to 4 y is equal x square equal to 8y, y equal to x square by 8 into dx, that is equal to 1 by 8 constant x square integration x cube by 3 limits 0 to 4, that is equals to 1 by 8 into 4 cube, upper limit 4 cube 64 by 3 minus lower limit 0, that is equals to 1 by 8 into 64 by 3, 8 cancelled in 64, say 8 times, that is equal to 8 by 3 square units, 8 by 3 square units, which is the required solution, which is the solution of the required given problem. The area of the region, bounded by the curve y is equal to x cube, x-axis, and the ordinates x is equal to 1, x is equal to 4 is 255 divided by 4, 155 divided by 4, third option 55 divided by 4, 355 divided by 4. First, draw the graph of the given function y is equal to x cube, x-axis and y-axis, and it is the origin. Y is equal to x cube. When this is the graph of the curve, y is equal to x cube. And the ordinates x is equal to 1, x is equal to 4, 0, and it is x is equals to 1, and it is x is equals to 4. To find the area of this region, 1 की 4 की मध्य line, so x is equal to 1, x is equal to a, and x is equal to 4 means x is equal to b is, therefore required area solution, required area A is equal to integral of limits 1 to 4 y dx, that is equal to integral of 1 to 4 y is equal to x cube dx. X cube dx integration x power 4 by 4 limits 1 to 4, that is equal to upper limit 4 power 4, 4 4s are 16, 16 into 16 256, 16 into 16, 256, 256 upper limit minus by 4 minus or lower limit 1 by 4, that is equal to 256, 256 by 4, denominator LCM 4, 4, 256 minus 1, 255. So, first one is the right answer, 250 of the given problem, area bounded by the curve y is equal to x cube and the ordinate x-axis and the ordinates x is equal to 1 and x is equal to 4. The area bounded by the curve bounded by the curve y is equal to 1 plus 8 by x square with x-axis and the ordinates at x is equal to 2 and x is equals to 4 is first option 2, second option 3, third option 4, fourth option 5. X-axis and y-axis. This is x is equal to 2, x is equal to 4 lines. 1 plus 8 by x square, y is equal to 1 plus y equal to 1 here, which is parallel to x-axis, and this is the curve, given curve 1 plus y is equal to 1 plus 8 by x square. So its area is solution, required area A is equal to limits 2 to 4 y dx, that is equals to integral of 2 to 4 y 1 plus 8 by x square into dx, that is equal to integral 1 dx x plus 8 constant 1 by x square integration minus 1 by x, so minus 8 by x, limits 2 to 4, that is equals to upper limit, that is equal to upper limit 4 minus 8 by 4 minus lower limit 2 minus 8 by 2, 4 times cancel, that is equals to 4 minus 2, 2 minus 2 minus 4, that is equal to 2 minus 2 plus 4 is equal to 4, which is the third option is the correct option. The area bounded by the curve, the area bounded by the curve y is equal to 4 minus x square, y is equal to 0, y is equal to 3 is first option 28 by 3, second option 32 by 3, third option 13 by 6, fourth option 23 by 3. First, area bounded by the curve y equal 4x square, ordinates y equal to 0, y equal to 3. First, draw the figure. A rough calculation here, y is equal to 4 minus x square. Even powers of x symmetrical about y-axis. So first we can write x square is equal to 4 minus y. This can be written as x minus 0 whole square. X minus 0 whole square is equal to minus common y minus 4. Check it. X minus 0 x square is equal to minus into y minus into minus plus, which is in the form of x minus h whole square equal to minus 4a into y minus k. Here vertex h comma k is equal to h is 0 comma k is 4, 0 comma 4. And next this parabola is open upward or open downward depends on the sign of 4a. Here 4a is a negative sign, it is a downward parabola whose vertex is 0, 4, right? X is 0, 4, this is 0, and 0, 4 lies on y-axis, x coordinate 0, y coordinate 4, 0, 4, and this curve, okay, vertex is 0, 4. This curve meets x, where it meets x-axis and where it meets y-axis. It meets y-axis at 0, 4 decided, and where it meets x-axis, put it meets x-axis means y equal to 0. If y is equal to 0, then 4 minus x square is equal to 0. X square is equal to 4. X is equal to plus or minus 2. So, the curve meets x-axis at two distinct points. One is at plus 2 units, minus 2. See here, this is a minus 2 and this is a plus 2. Curve meets, this is the curve of the given function y equal 4 minus x square. Y is equal to 0 means it is an equation. Y equal to 0 means x-axis, y is equal to 0, and y is equal to 3. It is the vertex 0, 4, 3, like suppose here 0, 3. Y is equal to 3 means which is parallel to x-axis, 0, 3. So, to find the area of the required region, this is the limitations of the boundary. Now, integral of y is equal to 0. Sometimes always we cannot take with x-axis, x is equal to b, with y-axis also here. So, x is equal, curve y is equal to 0 means y is equal to c, and y is equal to 3 means y equal to d, and x into dy. Therefore, required area is equal to, integral of y equal to 0 minus 2 to 0, this is one part of the region, and 0 to 2, two parts same area, equal area, that's why 2 times of integral of 0 to 3, this area. Next, integral of 0 to 3, this area. 2 times of integral 0 to 3 based with x into dy, where x is equal to g of y. Given curve is y is equal to 4 minus x square. That implies x square is equal to 4 minus y. X is equal to under root of 4 minus y. That is equal to 2 into integral of 0 to 3 x value root over 4 minus y into dy. ఎందుకు మనం ఇక్కడ x in terms of y లో తీసుకున్నామంటే వాడు క్లియర్గా y equal to 0, y equal to 3 అంటున్నాడు. y equal to 0, y equal to 3 means y equal to c, y equal to d. This is y is equal to 3. So, with y-axis, that's why x into dy, x is a function in the variable y. So, that's why x is equal to root over, from the given curve x square equal 4 minus y, x is equal to plus or minus actually, but we can take positive plus root of 4 minus y, that is equals to 2 into integral of 0 to 3 under root 4 minus y means root 4 minus y, you can write it as 4 minus y whole power 1 by 2 into dy. That is equals to 2 into, applying integration 4 minus y whole power 1 by 2 plus 1, 4 minus y whole power 1 by 2 plus 1 by 2 plus 1, 1 by 2 plus 1 into minus 1, because of y has a negative sign. That is equals to continuation, that is equal to 2 into minus 1 by 2 plus 1 3 by 2 into minus 1 minus 3 by 2. So numerator pass aithe minus 2 by 3, 4 minus y whole power 1 by 2 plus 1 3 by 2, limits 0 to 3, that is equal to minus 4 by 3, 2 into minus 2, minus 4 by 3 into upper limit 4 minus 3, 1 power 3 by 2, 1, upper limit 1 minus lower limit 4 minus 0, 4 power 3 by 2, 4 ni 2 square రాసామనుకోండి 2 square whole power 3 by 2 అవుతుంది. 2 square whole power 3 by 2, a power m whole power n, a power m into n, 2 will go, that is equal to minus 4 by 3 into 1 minus 2 cube 8, that is equal to 1 minus 8 minus 7, minus 4 by 3 into minus 7, that is equal to 28 by 3 square units, 28 by 3 square units, which is the first option is the right option. The area bounded by the x-axis and the curve y is equal to 4x minus x square minus 3 is first option 1 by 3, second option 2 by 3, third option 4 by 3, fourth option 8 by 3. ఓన్లీ కర్వ్ మాత్రమే మనకి ఇచ్చాడండి. లైన్స్ ఎక్కడ ఏమి లైన్స్ ఇవ్వలేదు. x is equal to a, x is equal to b కానీ y is equal to c, y is equal to d కానీ ఏమి ఇవ్వలేదు. దిస్ గివెన్ కర్వ్ బౌండెడ్ విత్ x axis, so first given curve is y is equal to 4x minus x square minus 3. If y is equal to 0, then 4x minus x square minus 3 is equal to 0. Now x square minus 4x plus 3 is equal to 0. Factors x square minus 3x minus x plus 3 is equal to 0. We can take x common, x minus 3 minus 1 common, x minus 3 is equal to 0. X minus 1 into x minus 3 is equal to 0. X is equal to 1, x is equal to 3. Therefore, area A is equal to, area limits వచ్చేసినాయండి. area A is equal to 1 2 3, x is equal to A, x is equal to B, 1 2 3, 1 2 3 given function y dx, that is equal to integral of 1 2 3, what is y? 4x minus x square minus 3 into dx, that is equals to 4 into x integration x square by 2 minus x square integration x cube by 3 minus 3 integration 3x 1 2 3, that is equal 4 into upper limit 9 by 2 minus 3 cube 27 by 3 minus 3 into 3 9, upper limit minus lower limit 4 into 1 square 1 by 2 minus 1 cube 1 by 3 minus 3 into 1 3, that is equals 4 into, this is 2 2s are 4, 2 into 9 18, 3 9s are 27, 18 minus 9 minus 9 minus 2 2s are 4 minus 2 minus 1 by 3 minus 3, 18 minus 18 0, minus 2 plus 1 by 3 plus 3. LCM 3 LCM minus 6 plus 1 plus 9. 10 minus 6, 10 minus 6 by 3, that is equal to 4 by 3, which is the 4 by 3 square units. 4 by 3 square units. Right. Next one, the area of the region, bounded by the curve y is equal to x square plus 2 whole square plus 2x between the ordinates x is equal to 0, x is equal to 2 is first option 436 by 15, second option 208 by 3, third option 236 by 5, fourth option 340 by 13. Given y is equal to x square plus 2 whole square plus 2x and x is equal to 0, x is equal to 2. Therefore, required area A is equal to integral of 0 to 2y dx, that is equal integral of 0 to 2y is equal to x square plus 2 whole square plus 2x into dx, that is equal integral of 0 to 2 expanding a plus b whole square x power 4 plus 2ab 4x square plus 2x a square x power 4 plus b square 2 square 4 plus 2 into a x square into b 2 4x square plus 2x dx, that is equals to integral of 0 to 2 x power 4 plus 4x square plus 2x plus 4 into dx, that is equals to x power 4 integration x power 5 by 5 plus 4 into x square integration x cube by 3 plus 2 into x integration x square by 2 plus 4 integration 4x 4 into dx integration x, limits 0 to 2, upper limit 2 power 5 32 divided by 5 plus 4 into 2 cube 8 by 3 plus 2 into 2 square 4 by 2 plus 4 into 2 minus lower limit 0 that is equals to, here 2 will go 15 LCM 5 3s are 15, 3 into 32 96 plus 3 5s are 15, 5 into 32 160 plus here denominator 1 15 4s are 60 plus 15 8s are 180 120, that is equals to 120 160 180 plus 100 280 340 plus 90 340 plus 90 436 divided by 15, which is the 4 square units. First option is the correct option.